Hello everybody. As you remember, last lesson I talked about oxoacids, acids and base. We introduced oxoacids as compounds containing hydrogen, a central element, and oxygen. And we mentioned oxoacids with different oxygen atoms have different names. And I asked you to name different oxoacids of chloric acid with different oxygens. So now I want to solve it for you. Okay, as you know, HClO3 is the reference oxoacid called chloric acid. I will write it at the middle of my slides. So it's chloric acid, the reference number. The reference acid. Addition of one oxygen atom leads to this chemical formula HClO4 with the prefix per chloric acid, and its anion, which is ClO4 minus, is named chlorate. Elimination of one oxygen atom leads to this oxoacid with the suffix of -ous, I told you. So it's called chlorous acid, and the anion ClO2 minus is chlorite with the suffix of -ite. Elimination of one extra oxygen from chlorous acid leads to another oxoacid called HClO with the prefix of hypo and the suffix of, again, chlorous, suffix of -ous, hypochlorous acid. The anion in this case is ClO minus, hypochlorite. Let's solve this question. What is the name of HF? Guidance. Remember the definition of acid that I told you in this lesson. Okay, I mentioned some of the acid compounds have different name, which is depend on the solvent that they reacts with. For example, in case of HF, if we consider it as a molecular compound, its name is hydrogen fluoride. It's a molecular compound, but if it reacts with water, since it produces proton, so its name is hydrofluoric acid. Today I want to talk about hydrates. Hydrates are compounds that have a specific number of water molecules attached to them. In its normal state, for example, consider this compound that I write you. CuSO4, which name is copper 2 sulfate. In its normal state, sulfate this compound has 5 water molecules associated with it. So this compound contains 5 molecules of water. So it has been written like that, containing 5 water molecules. The systematic name for this compound is copper 2-sulfate pentahydrate. So if I want to write the name, is copper 2-sulfate pentahydrate. And its formula is written as you see. The water molecules can be driven off by heating. When this occurs, the resulting compound is copper 2-sulfate. So if we heat this compound, the water molecules evaporates and the resulting compound is copper 2-sulfate after heating. Here is the images of this compound before and after heating. So the blue one is copper 2-sulfate containing 5 water molecules, and the white one is after heating. This compound, copper 2-sulfate, sometimes called anhydrous copper 2-sulfate. Anhydrous means that the compound no longer has water molecules as associated with. Some other hydrates can be called, like I will write here, barium chloride dihydrate, lithium chloride monohydrate, magnesium sulfate heptahydrate, magnesium sulfate heptahydrate. The other hydrates can be considered as well. A brief introduction to organic compounds. If I want to introduce you some organic compounds, let's talk about their features first. The simplest type of organic compounds is the hydrocarbons, which contain only carbon and hydrogen atoms. The hydrocarbons are used as fuels for domestic and industrial heating, generation of electricity, and powering internal combustion engines, and starting materials for the chemical industry. Okay, I mentioned one class of hydrocarbons are called alkanes. There is a general formula for alkanes, in this case, how to distinguish alkanes and how to write them using this formula. How it works: consider if n equals to 1, and if we substitute 1 instead of n in this formula, we can create this compound, which is called methane. The other compound, when n equals to 2, if we substitute 2 instead of n in this formula, we can have this compound, which is called ethane. And in the following, for n equals to 3, we can have this last compound, which is called propane. By substitution of n with different numbers until 10, we can have different alkanes, as you can see, butane, propane, hexane, heptane, octane, nonane, and decane. Well, the chemistry of organic compounds is largely determined by the functional groups, which consist of one or a few atoms bonded in a specific way. For example, when an hydrogen atom in methane is replaced by a hydroxyl group. If we replace the hydrogen atom in methane, consider the formula of methane is this, and if we substitute one hydrogen atom with hydroxyl or amino group or carboxylate group, we can generate different molecules with different properties. For example, with the substitution of one hydrogen atom with hydroxyl, we can have this compound instead of methane, which is called methanol. The other one, amino group. Instead of hydrogen, this compound is called methylamine. Methylamine. And the carboxylic group, which leads to acetic acid.